Welcome to class 9. We are going to be working on some solving of equations, which should make some of you pretty happy because it's your comfortable place. So a system of equations or matrix, which we are going to be talking about, in variables x, y, and z is said to be in upper triangular form if the first equation row contains an equation with at least x appearing, and the second equation does not contain an x and does contain a y, and the last equation does not have an x or y. And notice that basically what they're saying is that the equations make a triangle in here where we have 3 variables, 2 variables, 1 variable. So that's what they're talking about when they say that. And determine the solution of the set. So on this one, the first thing I'm going to do is start with this equation because that we can solve easily for z and then plug it back into the equation above it and then solve for y, and then we can substitute both z and y into that one to get x. So let's get started. I get z equals -1. And if z is equal to -1, y is equal to 2. And if z is equal to -1 times 2 is -2. If y is 2, I get 14. So I get -3x plus 14 minus 2 equals -19. So if I solve that, I get -3x plus 12 equals -19. I get -3x equals -31. That ain't a very nice number. Did I do something wrong? 14 -1 times 2 is -2, -19. I get 12. Yeah, it doesn't seem like... don't shy away from fractional answers, I guess. Alright. Geometric interpretation of the solution of a system of equations in 3 variables. So one solution means that a point of intersection of 3 planes. So we have 3 planes intersecting. They all intersect at the same point. Infinitely many solutions means there's a line. So we have 3 planes and they're meeting at the same line. And a no solution is at least 2 of the planes don't meet. Alright, so when we're solving via Gaussian elimination using elementary row operations and popular proper notation, good practice, make sure you're checking the answers when you're done. So elementary row operations, that means we're going to take and multiply a row by something that's not 0, and we're going to be able to interchange rows. We're going to be able to add a multiple of an operation to another row. So let's just kind of play with this one a little bit and see how it goes down. So if I take my first row, it seems relatively simple. Why don't I take row 1 times 2 and add it to row 2 and put it into row 2. So I can multiply rows times something, I can add them together. So if I do that, I'm going to get my first row stays the same. When I multiply the top row by 2 and add it to row 2, that means I have 2x minus 2x gives me 0, so that term goes away. I have 2y plus y gives me 3y. 2z plus z gives me 3z, and 2 plus -2 gives me 0. And notice that my third row did not change at all. And now if I do take the first row times -3, so row 1 times -3 plus row 3, and then I'm going to put it back into row 3. So if I do that, my first row stays the same. My second row would stay the same now. And my third row would be negative 3 plus 3 gives me 0. I have negative 3y plus 6y gives me 3y. I have negative 3z plus 6z gives me 3z. Negative 3 plus 5 gives me 2. And at this point, I notice that these two are the same, so I'm going to simply add, get rid of this 0, simply going to subtract row 2 and row 3 and put that in row 3. So I'm going to say row 2, negative row 2, well, let's just do it. Row 2 minus row 3 into row 3. So my first row stays the same. If second row is going to stay the same because I'm substituting it back into the third row. And I get 0 there. I get 0 there. And I get negative 2 there. And which makes it seem like there's going to be a problem because I'm going to say that I have 0x plus 0y plus 0z is equal to negative 2. So that seems like there is no solution. So that's how we do those elementary row operations. Now, can we do it without writing so many? Can we do it just by using the coefficients? So instead of having to write all the x, y's, and z's, can we write that as a matrix? So if I rewrite this first one as 1, 1, 1, 1, notice instead of putting the equal sign in there, I'm putting a dotted line. Negative 2, 1, 1, negative 2, and 3, 6, 6, 5. And notice we have the same operations we used over here, except for it's a lot less writing if we don't have to write x's, y's, and z's. We're just dealing with them as their pure number. So if we do the same thing here, we can do, write it as a matrix, 2, 3, 2, 5, and 1, 4, negative 3, 1. Now, we know because we have two equations but three variables that this isn't going to turn out very well. So it's not going to be one of those situations where we get just one answer. So what I'm going to do is I'm going to take row 2 times row 2 minus row 1, and I'm going to put that into row 1. And if I do that, I get 2 minus 2 gives me 0. Row 2, I'm going to put it into row 2. So the first row stays the same. Putting it in row 2, so 2 times 1 is 2, minus 2 gives me 0. 2 times 4 is 4, 4 minus 3 is 5. 2 times negative 3 is negative 6, minus 2 is negative 8. And 2 minus 5 is negative 3. So I can do the operations without the x's, y's, and z's in there. And we still get our solution where we know that this is still true, but we get infinitely many solutions because we didn't eliminate enough to get one solution. So we have infinitely many solutions in that case. So determine the solution to the set, and we can do it in one of two ways. We can use the matrix like I did above, or we can use simplifying. And just for the fun of it, I'm going to do some simplifying, try to solve it. And the best way to do that is to use some of this row operation stuff. So I'm going to take, well, hold it. Instead of showing the whole thing, I'm going to pause here and come on when I get the next step so it doesn't take so long. So I turned it into a matrix. So then I took 2 times row 1 minus row 2 and put it in for row 2, which changed that row. So now I took row 3 minus 7/3 times row 1, and I got the 7/3 by using those two coefficients to get this term to be 0. Now my next goal is to get this number to be 0. So I'm going to do that. So to get 0 in the last row second position, I took row 2, which was the 4, plus 2 row 3, which is 2 times the -2, and then I put that in for row 3. And you can see what happened here. I get 13/3 z equals 13/3, so I end up with a z equals 1. And if I plug that into, now that I have this triangle in here, I can just put the rest of them in there. So 4y plus 1 times 1z equals 13. I get 4y equals 12. Y must be 3. And then I can put into the third equation, the top equation, I get 3x plus 3 times 3, which is the y, minus 2 times 1, which is the z, is equal to 13. And I get 3x plus 9 minus 2 equals 13, or 3x, by subtracting 7 from both sides, I get a 6 over there, which gives me an x of 2. So I get x of 2, y of 3, z of 1. And the way to write that, because it's a point in 3 space, so I would say x, y, z. So let's stop there and we can start on section 3 in the next video.